So to prove this identity, what we're going to do is we're going to work with the right side of the equation. We're going to multiply the right side of the equation by the number 1 written in a funny way. And this might seem a little bit random, but we're going to multiply by tan x minus secant x minus 1 over tan x minus secant x minus 1. This is a complicated algebra kind of a problem. But the bottom line is you're going to multiply each piece here times each piece in the trinomial, and you're going to end up with sort of a really complicated looking expression that is this. And I'll let you prove to yourself that actually is what you get. You get each of these pieces, tan squared plus 2, plus there's actually 2 of these tangent secants, and there's actually a positive and a negative of the tangent here on the top, and a positive and negative of the secant that get to cancel out. On the bottom, that's not quite so pretty, but we can actually combine a few things. There's 2 tangent squareds. There's 2 tangent secants, and there's 2 minus tangents, and there's 2 minus secants. So anyway, if we combine all those together, the bottom line is we get this. Tan squared x plus 2 tan secant plus secant squared minus 1. And if I move the 1 next to the tangent squared here, I'll get tangent squared plus 1. And then plus the rest of this. Now you'll see that here we have Pythagorean identities. Secant squared minus x is equal to tangent squared, and tangent squared plus 1 is equal to secant squared. So we can use those identities, and the top then, I'm going to rewrite the top. The top turns out to be that, and so I'm actually going to just I'll leave it up above here, and I'll just cross this out. And the bottom turns out to be actually what we can do here is, you'll notice here that I've got 2 tangent squareds here, so I'm just going to combine those together and into a single expression, and we'll call it 2 tan squared x plus 2 tan secant. So that top simplifies down pretty nicely. The bottom, we can do the same kind of thing. The bottom, we end up with a secant here, secant squared, and you'll notice we have another secant squared that we can combine together. So I'm going to do that. I'm going to just combine those together, so you've got those in one piece. So this top then, or the bottom, the denominator turns out to be 2 secant squared plus 2 tangent secant minus 2 tangent minus 2 secant. Okay, well at this point we're going to do some factoring. So the top here I can factor out a 2 tan. And so I'm going to do that. I'm going to factor out a 2 tan. And when I do that, I'm going to replace this top with this expression. Now to make this simpler here, I'm just going to, I'll move this aside here just so you'll have it as a reference here. But to save space here, I'm going to just delete this stuff here. This is the new top, the factored top. 2 tan was factored out, and what's left inside after I factor out the 2 tan is tangent x plus secant x. On the bottom, I'm going to actually factor by grouping. So I'm going to group the first 2 things together, and I'm going to group the second 2 things together. the first two things, I'm able to actually factor out a 2 secant of x. And the second two things, I'm actually able to just factor out a -2. So when I do that, I'm going to get this expression. So I'm going to, again, scoot this over so you have it as a reference here. But my denominator now becomes 2 secant, parentheses, secant plus tangent, minus 2, parentheses, tangent plus secant. Now I can actually switch these around because there's just an addition problem here. And so you can see here that I can actually have a common factor on the top and the bottom. Tangent plus secant. Tangent plus secant, tangent plus secant also have the number 2 on the top and the bottom. So I'm going to actually cancel out the 2, cancel out the tangent plus secant, cancel the 2 and the secant and the tan secant, cancel the 2 and the tan secant. So what's going to be left is, on the top, tan x, on the bottom, secant x minus 1. And that's what we were looking for. I hope this was helpful. And it seems a little bit random, but you can see here it got really complicated, but then it simplified down really nicely.